Hey guys, this is test 50, game 1. This is the Airlines game. It is an ordering game. We know this because there are 6 consecutive stops, 1 through 6. As such, there must be an order in which they occur. Now, I've laid out a bunch of different rules here, but I'm going to explain all of those. The 1 through 6 forms our base because that's the ordering. Then we're taking the airlines L, M, N, O and placing them in each of the 6 stops. So, of course, if there are 4 things, 6 stops, there's going to be some repetition. They give us a few rules that I've diagrammed and will explain. They tell us that no airline goes consecutively, so I put XX with a slash through it. They tell us that 1 and 6 are going to be the same, so I laid out an arrow going from 1 to 6 and vice versa. Whatever's on 1 will be on 6. They're the same. Whatever's on 2 will be on 4. Those guys are the same. And then L is never followed by N immediately, nor is M ever followed by N immediately. Then finally they tell us that either N or O will be on airline number 5. So this right here is our initial setup for the game. Obviously we'll be drawing a lot more over the course of the questions. Now question number 1 is a typical orientation question. Just take one rule at a time and apply that rule to all 5 choices looking for violations. So for example, we know that 1 and 6 have to be the same. If they're ever different, it's a bad scenario. Scanning through the choices, we see that choice E has different things on 1 and 6 that's unacceptable, so E can be eliminated. Next, we could use the rule that 2 and 4 have to always be the same. Looking through the choices there, we see that both A and B violate this, having different things on 2 and 4. Then finally, we could look for either N or O always being on 5. If you scan through the choices there, you see that all of them have N or O on 5, so that one's not helpful. But finally, we could use the rule about LN and MN. We could never have LN consecutive in that order, nor can we ever have MN consecutive in that order. Scanning through the remaining 2 choices, C and D, we find that choice C has MN consecutive in that order, so C is bad, and D is our answer for number 1. Next, number 2, if we had N on 5. So if N's on 5, N cannot be on 4 or on 6 because we can never have the same thing occurring consecutively. And then because 4 and 2 have to be the same, N cannot be on 2 and N cannot be on 1 because if N was on 1, it'd have to be on 6, and we can't have those things consecutive. So space number 4 cannot be N. It can also never be either L or M due to the fact that we have N on 5, and L and M cannot be consecutive with N in that order, so neither L nor M can be on 4. So none of N, L, M could do it. That just leaves O because there are only 4 airlines. So we know that 4 is going to be O. And because 4 is O, we know automatically we cannot have O on 3. So starting with that, we'll get pretty far. Scanning through the choices, they're asking about stops 1, 2, and 3. We know that O can never be on 3, so D is eliminated for that reason. We know that N cannot be on 1, so E is eliminated for that reason. Got rid of 2 so far. Then finally we have the LN-MN rule. So scan through just the choices themselves. We see A violates that having MN on A, so that's gone. We know that, let's see what else, we can look for LN in the remaining ones, B and C. We see that, yes, in choice C we have LN consecutive as well. Unacceptable, so C is gone, leaving B as our answer for number 2. Next, number 3, if the only airlines used were M, N, and O. So right away we know that L is not going to be picked. We only have 3 things to choose from, and so things are going to be incredibly limited here. They're telling us also that O has to be on 5. So if O is on 5, automatically we know that O is not on 4 or 6 because we can never have the same airline going consecutively, and because 6 and 1 have to be the same, we know that O cannot be on 1. Because 4 and 2 have to be the same, we know that O cannot be on 2. So there's a lot of places O can't go. The only place it might go right now other than 5 is 3. So O cannot be on either 1 or 2, we know. So for that reason, we can eliminate A, which has O on 2. We can eliminate D, which has O on 2, and eliminate E, which has O on 1. So we already got rid of a couple here. We can now look for these violations, LN, MN. Scanning through the choices here, we see that choice B has MN, unacceptable, so B is gone, leaving C by elimination for number 3, and you could have also eliminated E due to the fact that it had MN as well. So C is our answer for 3. Next, number 4, what cannot be an accurate list of places that the airline stops on 1 and 2? So We could use some previous valid scenarios here, whatever we might have drawn in the past. We see that question 1 has D, M, O. We know that worked, of course, so for that reason, we can automatically eliminate D from the list of choices here since we've seen that it could work. Other than that, though, we're going to have to essentially run through the choices here, so I'll just start doing that. Looking at A, LM, if we have LM on 1, 2, of course, if L's on 1, it has to be on 6. If M's on 2, it has to be on 4. And so, does this work? Well, of course, we could never have MN, so if we have M on 4, we can't have N on 5. 5 is going to have to be O. And everything checks out. We're not violating any of these. We can't put M here, but other stuff wouldn't be a problem. So it works out perfectly fine. A can be eliminated. Next, looking at B, LO on 1, 2. If O's on 2, O's on 4. If L's on 1, L's on 6, of course. O's can't be consecutive, so we'd have to have N on 5, and then O couldn't be on 3, but other things could. Again, works out perfectly fine. Doesn't violate anything, so B can be eliminated as well. Next, looking at C, M, L on 1, 2. If M's on 1, L's on 2. If L's on 2, L's on 4. If M's on 1, M's on 6. We can never have Ln, so we'd have to have LO. Again, L couldn't be on 3. N could not be there, but maybe M could, maybe O could. Not really any problems there. Doesn't violate anything, so C is eliminated as well. So by elimination, E is our answer. You could just pick it and move on, but I'll explain it though. If O was on 1 and N was on 2, N2 requires N4, which would require O5. The problem here is that O1 requires O6, so now we have O's occurring consecutively, unacceptable due to the first rule of the game, so for that reason, E could not work. We could not have O on 1 and N on 2. Next, number 5, if we had O on 2. So if O's on 2, of course, O has to be on 4 as well. If O's on 4, N has to be on 5 because O's can't go consecutively, just as nothing can go consecutively. So the only place we might have O remaining here would be 3, because if O can't be, actually no, O can't even be 3 because we have 2 and 4 on either side. Since O's on 2, O cannot be on 1, and since O cannot be on 1, O cannot be on 6. So O cannot be used again in this game. So we'll just run through the choices with that. What could be on 5 and 6? Obviously, O could never be on 5 and 6, so any choice containing O on 5 or 6 is automatically eliminated. So we get rid of C, D, and E off the bat. We're down to A and B. Of course, we've realized that N has to be on 5, so B is our answer because A does not contain N on 5. Additionally, of course, MN can never be consecutive in that order, so A is eliminated for that reason as well.